tan inverse of root over 1 plus cos x plus root over 1 minus cos x divided by root over 1 plus cos x minus root over 1 minus cos x. Now this you have to simplify and prove that this is equal to pi by 4 plus x by 2. X less than pi by 2 greater than 0. Now this is the interval given for x. Now we can simplify this one. Tan inverse of, we can simply rationalize this, or we can do one thing. We can directly write it here. That the formula of this one we know 1 plus cos x is what? It is root under 2 cos square x by 2 plus root over 2 sin square x by 2 divided root over 2 cos square x by 2 minus root over 2 sin square x by 2. Now tan inverse of we can write here mod cos x by 2 plus mod sin x by 2 divided mod cos x by 2 minus mod sin x by 2. Now the interval which is given to us, the interval which is given to us is this x greater than 0 less than pi. Now from here x by 2 will be what? Greater than 0 less than pi by 2. Now here cos x by 2 comma sin x by 2 greater than 0. Here both the now here x by 2 is lying from what? From 0 to pi. So cos x by 2 and sin x by 2 is what? Greater than 0. If it is greater than 0, both the numbers are greater than 0. So mod of this one we can write cos x by 2. Mod of this one we can write sin x by 2. So here you can write tan inverse of cos x by 2 plus sin x by 2 the whole divided cos x by 2 minus sin x by 2. Now the interval where it is given x by 2 is lying, it is never equal to cos x by 2 will be never equal to 0. So you can divide the numerator by cos x by 2. So what we get here? Tan inverse of 1 plus tan x by 2 by dividing by cos x by 2, we get this by 1 minus tan x by 2. Now this can be written as tan inverse of tan pi by 4 plus tan x by 2 whole divided by 1 minus tan pi by 4 tan x by 2. So it is tan inverse of tan pi by 4 plus x by 2. It is tan inverse of tan pi by 4 plus x by 2. Now x by 2 lies from what? From 0 to pi by 4. Now if we add pi by 4 from, that is we have here so x by 2 lying from what? Greater than 0 less than pi by 4. So x by 2 plus pi by 4 will be less than pi by 2 greater than 0. Now here what we can say, tan inverse of tan pi by 4 plus x by 2. It is lying from what? From 0 to pi by 4 to pi by 2. What we observe here is lying from what? If we add pi by 4, this will be, that is when x by 2 is greater than 0 less than pi by 4. If we add pi by 4, it will be greater than pi by 4 less than pi by 2. So here this whole value lying from what? Pi by 4 to pi by 2. Now tan inverse of tan x will be what? X when when that x lies from minus pi to pi by 2. So that x lies from what? That is what we can say that tan inverse of tan x equal to x when x belongs to minus pi by 2 comma pi by 2. So here now we can write tan pi by 4 plus x by 2 equal to pi by 4 plus x by 2. Why you can write this? Because it's lying from pi by 4 to pi by 2. It is given cos inverse of cos x plus cos y will divide by 1 plus cos x cos y equal to 2 tan inverse of tan x by 2 tan y by 2. So this is what you have to prove. It is given what? Cos inverse of cos x plus cos y by 1 plus cos x cos y. And you have to show that it's equal to this. How to start with? Very simple. We started in this way that let cos inverse of cos x plus cos y by 1 plus cos x cos y equal to theta. We take this whole thing as theta. Now, if you take this whole thing as theta, then we can write here cos x plus cos y by 1 plus cos x cos y equal to cos theta. Now, after this, you can apply component difference. Why? Well, how to understand here? We will apply component difference. Because we know there is a formula 1 minus cos theta by 1 plus cos theta equal to tan square theta by 2. So here we apply component difference. So like using component and difference, we get what? Cos x plus cos y plus 1 plus cos x cos y whole divided cos x plus cos y minus 1 minus cos x cos y equal to 1 plus cos theta by cos theta minus 1. See what we have done. Just the using component difference. 1 minus 1 plus cos theta is this one. We know, so we want to bring it in that way. Now, if we take a minus common from the LHC analysis, what we write? 1 plus cos x plus cos y into 1 plus cos x. Now here we take a minus common. Plus cos x cos y equal to 1 plus cos theta by 1 minus cos theta. So here also I have taken a minus common. Now this minus will get cancelled out. And now on simplified terms, what we get? 1 plus cos x into 1 plus cos y by 1 minus cos x into 1 minus cos y equal to 1 plus cos theta by 1 minus cos theta. This is what. Now 1 minus cos x by 1 plus cos x, that is just what? If you take the just the reciprocal, or let us take the reciprocal and write the simplified step. 1 minus cos x by 1 plus cos x into 1 minus cos y by 1 plus cos y equal to 1 minus cos theta by 1 plus cos theta. Now this is what? Tan square x by 2, tan square y by 2, tan square theta by 2. So here we take tan theta by 2 as one of the value, as tan x by 2, tan y by 2. Now here both are possible, plus as well as minus. But here we take the positive value only. Why? If this is the negative number, then this whole value will lie from what? From minus pi to 0. But cos cannot give us a value from minus pi to 0. So here, this assumption has a logic. That why we are taking here positive. This value, or you can understand this way. The cos inverse of cos x plus cos y by this one. Now here, this theta will lie from what? This theta will be greater than equal to 0, less than equal to pi. Though here it cannot be equal to pi also. Why? This is tan inverse. So it can be only less than pi. If it is from less greater than equal to 0, less than pi, because it's cos inverse. So theta by 2 will lie from what? Greater than 0, less than pi by 2. Now in that respect, this will be definitely positive. So this has to be positive. Now I have taken both positive and we got this. Now from this what we can write theta equal to 2 tan inverse of tan x by 2 tan y. Done. Now we come to question number 13. Half of cos inverse 5 cos x plus 3 pi. 5 plus 3 cos x. Now do we have to prove this equal to tan inverse half tan x by 2. Now here there are many ways we can proceed. That is, one of the methods that we can consider this as theta, and then we can do exactly what we have done the previous one. That is what I mean to say. That is here LHS. Let half of cos inverse 5 cos x plus 3 pi 5 plus 3 cos x equal to 3. Now from this what we get 5 cos x plus 3 by 5 plus 3 cos x equal to cos 2 theta. Now we can write this one 5 plus 3 cos x by 5 cos x plus 3, just we have taken the reciprocal, equal to 1 by cos 2. Because if we take the reciprocal, it is easy for us to apply complementary and get that form. Actually, our intention is to get this format 1 minus cos 2 theta by 1 plus cos 2 theta equal to tan square theta. So now we use here component division. Using component 2 and dividend, we get 5 plus 3 cos x plus 5 cos x plus 5 plus 3 cos x minus 5 cos x minus equal to 1 plus cos 2 theta by 1 minus cos 2 theta. Now this gives us what? 8 plus 8 cos x. It is 8 plus 8 cos x divided by 2 minus 2 cos x equal to 1 plus cos 2 theta by 1 minus cos 2 theta. Now if we simplify this one, what will we get here? 1 minus cos 2 theta by 1 plus cos 2 theta, which I have taken from the RHS. And here what we get? 1 minus cos x by 4 comma 1 plus cos x. Now this will give us tan square 2 theta. Tan square theta. This will give us tan square theta equal to 1 by 2 tan square x by 2. Now we are dealing with half of cos inverse of this equal to theta. So here theta should belong to what? Theta should be here less than pi by 2 greater than equal to 0. Why? Since it is cos inverse, it can give us value from 0 to pi. But if it is pi 2 is there, so it will give us from 0 to pi by 2. Now in 0 to pi by 2, this is a positive number. So this must be also positive. So from this what we can know that tan theta equal to half of tan x by 2. So from this theta is what? Tan inverse of half of tan x by 2. And there's a logic also in writing tan inverse because the interval which we are dealing with, that is from 0 to pi by 2. And in this interval, tan is invertible. In this interval, tan is invertible. That is here, we can say that as, why could we write this? Here also we have to write a reason that theta is greater than equal to 0 less than pi. That is the reason we could take positive value less than pi by 2. And why could we write the inverse here also? Because here you can see that arc, or do it right arc, just you write here as tan function is invertible when x belongs to minus pi by 2 to pi by 2. And here the value is lying from what? From 0 to pi by 2. So obviously invertible. It is given tan inverse of 1 minus x by 1 plus x plus minus tan inverse of 1 minus y by 1 plus y. And we have to find the RHS form, which is given as, which you prove sine inverse of y minus x by under root of 1 plus x square into 1 plus y square. So this is what we could do. There is tan inverse of 1 minus x by 1 plus x minus tan inverse of 1 minus y by 1 plus y equal to sine inverse of y minus x by root under of 1 plus x square into 1 minus 1 plus y square. Now, how can we proceed here? That is, this we can write as LHS or form LHS. We have tan inverse of 1 minus tan inverse of x minus tan inverse of 1 minus tan inverse of 1. Now that is tan inverse of y minus tan inverse of x. So here what we get, tan inverse of y minus tan inverse of x. How? Very simple. Minus into minus, it will be plus minus tan inverse of x. Now this is what tan inverse of y minus x by 1 plus x is what it is. Now from this, here since nothing is mentioned, we consider the all simplest cases, the conventional processes or conventional intervals which you take. That where we have to the simplest cases or there is no deviation from the conventional method. So in that respect, I consider this as positive. Now, if it is positive, we can apply triangle method and get it converted to sine. So this is theta. And tan theta is y minus x by 1 plus x. That will be what? This is y minus x into k. And this is 1 plus xy into k. And the hypotenuse will be under root 1 plus xy whole square plus y minus x whole square. This into k. Now, if we simplify this part, what we should get? Just if we simplify this part, 1 plus x square y square plus 2x xy plus 2x xy. It is x square plus y square minus 2x xy. That's why we get cancelled. So ultimately, this we get k into under root of 1 plus x square plus y square plus x square y square. Now this one further simplification, what we get? Root over 1 plus x square into 1 plus y square. Very simple. You can take 1 plus x square here common as, or you can say as a single term. Now if you take y square common, 1 plus x square again, and you get this. Now you can convert this to sine inverse. Sine inverse y minus x by under root of 1 plus x square into 1 plus y square. So this is what it is. Cos inverse of x plus cos inverse of y equal to theta. And we have to prove x square minus twice xy cos theta plus y square equal to sine square theta. So this is what we need to prove. Now, since this is straightforward thing, so what we from the given condition we can apply here cos inverse of x plus cos inverse of y formula. So here we'll apply cos inverse of y formula, but before that, as we always assume here that x and y is lying from -1 to 1 and x plus y greater than equal to 0, so that we can apply conventional formula. So here, assuming x plus y greater than equal to 0, because since cos inverse of x and cos inverse of y exist, so automatically these values will lie from -1 to 1. That is which one we are applying? We are applying this formula, cos inverse of x plus cos inverse of y equal to cos inverse of xy minus under root of 1 minus x square into root over of 1 minus y square. And this formula can be applied when xy lies from -1 to 1 and x plus y greater than equal to 0. We can apply this formula under this condition. So this is already the assumed part, and x and y must be lying from -1 to 1 because cos inverse of x and cos inverse of y exist here. So we apply the formula cos inverse of xy minus under root 1 minus x square into 1 minus y square equal to theta. Now we can write here xy minus 1 minus root under of 1 minus x square into 1 minus y square equal to cos theta. Now while solving these cases, what we do, we take all the rational terms one side and the irrational term on the other side. So we can write here xy minus cos theta equal to under root of 1 minus x square into 1 minus y square. Now squaring both sides. Squaring both sides. As you can see in the proof, we have x square plus y square. So we definitely need to square it. So this gives us x square y square plus cos square theta minus twice xy cos theta equal to 1 minus x square minus y square plus x square y square. Now this one simplification what we give x square plus y square minus twice xy cos theta equal to 1 minus cos square theta, that is equal to sin square theta. So what we have done at first, cos inverse of x plus cos inverse of y equal to theta given. So we are just assuming this one x plus y greater than equal to 0 because we want to apply the conventional formula which can be applied only when x and y lie from minus 1 to 1 and x plus y greater than equal to 0. Now here since cos inverse of x exists, cos inverse of y exists. So x and y should lie from minus 1 to 1. This is the assumption part we have taken. Now here we have applied the formula. Now xy minus this one equal to cos theta. Now here I have done again that assuming that this is equal to cos theta without use of any generality and in the simplified case. And now I have taken cos theta on the left and I have taken this root under of 1 minus x square into 1 minus y square on the right hand side. Why? So that all the rational terms on one side and irrational terms on the other side. Now squaring both sides, we have got this. Now here also whenever we are using these terms that it is a rational term on one side, irrational term on the other side. Here also we are assuming that this is not a perfect square. So that is the reason we are using the term that it is a irrational number and is a rational number. But this all can also give us irrational value. For example, cos theta can give us the value root 3 by 3. Irrational number. But here when we are doing the sum, we are assuming in that way for our calculation part and then we are solving. Sin pi cos theta equal to cos pi sin theta. Now here what we do, we convert sin to cos. Cos pi by 2 minus pi cos theta equal to cos pi sin theta. Now when we have cos theta equal to cos alpha formula, what we do? We write the general formula. What is that? Cos theta equal to cos alpha means theta equal to 2n pi plus minus alpha. So here also we do the same thing. That here pi by 2 minus pi cos theta equal to 2n pi plus minus pi sin theta. Now here we divide by pi throughout, so we get half minus cos theta equal to 2n plus minus sin theta. Now we take sin and cos on one side, so plus minus sin theta plus cos theta. equal half minus 2. Half minus 2. Now, since we have to find the inverse of this, that is, in according to the question, we need to find the value of theta. That is, we have to show this equal to plus minus half of sine inverse 3 by 4. So we can say that we can searching for the principal solution. So it won't be the general solution for it. So here to get the principal solution, I put n equal to 0. So to get the value in principal range, what we do? We put n equal to 0. Now, after putting n equal to 0, what we get? Some plus minus sine theta plus cos theta equal to half. Now, squaring both sides. On squaring both sides, what we get? Sine square theta plus cos square theta plus minus 2 sine theta cos theta equal to 1 by 2. Plus minus sine 2 theta equal to minus 3 by 2. So we have plus minus here, we can transfer it on this side, and we can write here 2 theta equal to plus minus sine inverse of 3 by 4. And this gives us theta equal to half of plus minus sine inverse 3 by 4. So already we have told that we are trying to get the value in principal range. So here sine inverse will definitely exist. So you can write theta equal to plus minus half of sine inverse of 3 by 4.